Before I begin, let's take a few steps back and try to understand what is the problem we are facing. So we have two types of issue. One is the type of the data, and the other one is the amount of data. The type of data is our videos and video and audio files that are unstructured data. That means that there are a sequence of numbers and bytes. They're not well organized and they don't have an internal structure. And because of it, it's really hard to understand for the computer. We as human beings understand it, but for the computer, it's really hard to understand what is the meaning of the information. The other thing is the amount of data. And these days, there is a huge amount of digital data that's uploaded to the networks and around us. And just for examples, Instagram users are uploading more than 100 million photos and videos per day. YouTube users upload 400 video hours per minute and watching 4 million hours per minute as well. This is really huge amount of data, and it's really hard to search on this data and get insights. Now, let's take it to the single user, to you. Try to imagine yourself, your parents celebrating this year their 40 years anniversary, and you're the one who need to edit this family video and try to find all of the places that one of your parents appears in video families from the past 20 years. How long it's gonna take? Probably days. Now imagine that you have this magical tool that can do it for you, can detect all of the places that these faces or people appears and bring you the exact spots and places. Well, this is the video indexer, okay? How do we do it in video indexer and in general? So usually we use machine learning capabilities that know to understand the internal representation or the unstructured data and to get insights out of it. Let's go to the video indexer. Video indexer knows to get videos, sequence of images and the audio, process it using AI and ML capabilities, and in order to extract these insights, such as face recognition, OCR, and much more that I am going to elaborate. I will talk today about the video indexer. I will focus on two types of domain, the visual and the auditory one. And also, I will explain how we can combine these two processing type or two type of signals into higher level insights that are related to human language. This is how it looks like. This is the website that you can work with video indexer. You're uploading a video, it indexing the video, and then, no, it's good. On the left-hand side, you can see the video that you were upload, and on the right-hand side, you can see all the insight that you got out of the video indexer, the faces, topics, labels that I will explain soon. As I mentioned, there are two modalities, the visual one and the auditory one. And in each type of this signal, we have several topics that, or several tasks that we can do in video indexer. On the visual one, we have all the object level understanding, which is the object detection, for example. Then we have all the textual level information, for example, to detect and understand the character, the letters, the words. And we have all the video level information, which this is all the information we can understand when looking at the whole image or over sequence of a few images. On the auditory domain, we have all the acoustics, analyzing the sound that we hear. Then we have a particular and unique sound that's called the human speech. We can analyze it as well. And also we have some speaker-related information that we know how to extract. If you look over these 6 types of topics, the speech one and the textual level are the ones who related to human language. Okay, now let's focus on the visual one and see examples for features that we have on video indexer. So I mentioned the video object and textual level. On the video level, we know how to get insight that's related to temporal units, such as scene. We know to detect the beginning and the end of each scene in your video. Then we know to detect credits, the credits in the end of the video. Sometimes there are, in series and episode, etc. We also can classify and understand what is the content in the video and to see if we need to restrict it somehow. On the object level, we know to detect and classify into labels the object that appears in the frame. We also know to do face detection and recognition, and we have some capabilities that related to animated character. And on the textual level, as I already mentioned, we are doing OCR, optical character recognition. Let's see some example that related to face detection and grouping. So this is output of video indexer from a specific movie clip that uploaded to the video indexer. The video indexer detected 36 people in this particular clip. You can see their faces, and here you have one of the women that called unknown one, if you can see here, because the system doesn't know it. She appears 7.7% of the time, and then you have the timeline over here, and you can see all of the places that this woman appears. Okay, now, other than the detection, we have the grouping part, and you can see here 3 places on the timeline that this woman appears, and you can also see that this task is not that trivial because her face is different. It has different sizes. She looks to different angle in different poses, and this is why it can be difficult sometimes. But after we did the detection and the group together, we also want to recognize. So we have our celebrity model recognition. For example, this movie. And we recognize, we have up to 1 million celebrities that we know how to recognize. And you can see here a video with President Trump. Video indexer detect 23 people in this particular movie, and it recognized Donald Trump as the President of the United States. You also see 2 other people in this image, in this frame, and video indexer indeed locate them as well and recognize them as Robert Whitfield, the director of the CDC, and the Vice President, Mike Pence. Now, another type of celebrity that I already mentioned are the animated character. And this is a really nice and cool feature that we added in the past year to Video Indexer. And we can recognize well-known animated characters. You can see here Dora and SpongeBob. And like the face detection, it can be hard sometimes and difficult, and here we have other challenges because the variety of a character, an animated character, is much larger than the variety of our face. For example, Bob Sponge can be, first of all, it has like square head, it's not that human. Then, the eyes is changed, his color changed sometimes. There are scenes that he like split into parts, and we need to detect all these events. On the image level, we know to do credit detection. We know to detect the exact moment, the exact frame that the credit are beginning. Now, what is the feature? You're probably familiar that you see your, on your online streaming service, your favorite series, and on the end of the episode, you just think if you want like 2-3 minutes break, and then it detect the credit and skip you to the next episode and doesn't ask you if you want or not. So this is the motivation, the application here. It may seem easy because it's like text on plain background, but no, it's not always plain. It can be over images with different, types of shapes, and you can see here examples on the bottom and the middle. For me, this is look more like a computer code than credits, but this is credit. It can roll up, down, to the side. It can be static. There are more like a lot of variation over it. Another thing that we do is the optical character recognition that I also mentioned, and here the problem is that, as I mentioned, is unstructured data. So the computer see the pixels, the number, and it doesn't understand, he need to understand that these pixels are actually letters. He need to detect them to recognize and understand that they are part of a specific, I don't know, known character or language. And there are other challenges, like this person who occlude the letter M in Microsoft, and we also need to use like temporal processing to understand what is the word that behind that person. An example for video indexer output, this is Satya Nadella, Microsoft CEO, and here you can see that video indexer understood the word, I'm not sure that you see, but it's written here, Microsoft, Satya Nadella, and his title. And we can use this information, and I will show you next how we use this OCR to do some higher level processing. That was part of the feature we have on the visual domain, and now let's go to the auditory domain and try to see what we have over there. So we have the speaker, speech, and acoustic parts. On the acoustic parts, we're doing voice activity detection. That means we detect the exact places that we hear voice and not silence or not some other sound which are not human voice. On the speaker part, we are doing speaker diarization. That means that we know to recognize the exact segments that the speakers spoke. And in that example, you see three speakers, A, B, and C. And speaker A spoke twice, at the beginning and in the middle of the segment. Then on speech, we have the language identification and the STT, speech to text or transcription. And let's see example for these tasks. It's not only that we are doing language identification, we're also doing multi-language identification. Even if we have one video or one audio with many languages, we can find the exact spots. So here is another example of President Trump and Macron, who obviously talked French and English, and video indexer located, you can see here the French and then the English ones, and you see that like it's part of it is French, part of it is English, because there was also translate in between. And you see a picture from the French segment, and you see that President Macron is talking. Then you have segment that President Trump is talking, and at the beginning here, you have places with no language that was identified, and this is because there was no talking. This is the voice activity detection. How do we do it? So we have our own model to detect the different languages. We split up the utterance or the audio into small frames. This is what you can see on the top line here. Then we smoothen the output of the model to get the exact segment of each language. Let's see an example of the video indexer of this specific video. So the user jump on the left side between French and English.
Now we are thrilled to host you.
I'm skipping between all the places with English now.
George Washington fought bravely in the battle. The Americans to storm the cliffs of Omaha Beach.
I also skip to the places where President Macron is speaking, and there is a translate.
We shall continue to build and ride together, but also to the oceans, but also to biodiversity, and to all forms of pollution.
Okay, so this is the multi-language identification. And now let's talk about the speech to text. So we have our model that knows to convert between the acoustic signal, the speech, into text, but we also have another feature that's called customized language model. And why is that? Because the general model usually trained over day-to-day speaking, but usually when you change to different domain, you have different jargon. And these are some examples. The tech domain, medical domain, finance domain. In each one of these domains, domain, there are like different words that occur in different frequencies. For example, in the tech domain, you probably know the word cloud, which is appear much more frequent than the day-to-day use, and it has also different meaning. Another word, Kubernetes. I mean, it's not word. Someone that is not in our domain doesn't know this word, and obviously the day-to-day speech-to-text model doesn't know it. So we provide the user the opportunity and the option to custom its own model. How do we do it? So let's do a quick review of how speech-to-text is working. We have the signal that get into the system. We have the acoustic model, language model, and the lexicon. The acoustic model is translating the signal into phonemes. And you can see here an example of a few signals with a few phonemes and the probabilities that each one of them represent this phoneme. Now let's take a very popular word this day, corona. And let's try to think that we have this word and the acoustic model recognizes this phoneme, but now we need the language model that will try to estimate what is the probability that this word exists and what is the probability that this word exists together with another word after it. So let's look at the general language model, and then we can see phrases like Corona beer, Corona extra, Corona brand. And maybe we have the coronavirus really like on the bottom with something like 0.something% of probability. We provide the user the option to upload its own text file to Video Indexer with many types of sentences like part of Italy due to the coronavirus outbreak, etc., etc., etc. We retrain our language model to create the customized language model. And as you can see here, the coronavirus phrase got up with really high probability. Okay, now after we did the visual processing and the auditory processing, now we have many insights that we provide the user and give it can use it. But other than that, we can run more algorithms. We can take the OCR, the face identification, the transcription, to take them all together, to combine them together with external sources like Wikipedia and more, and to fuse them together to get human language insights. What exactly we give here as a features? So we can locate all the names that appears in the video or the audio, such as famous location, famous names, brands and company names. We can also say that these and these were the keywords that appear in this video or audio. We can understand the sentiment of the video, if it was positive or negative, and we also can understand the topic. Okay, the topic is not always appear in the video, but we can understand it by combining all this information. Let's see another example from the same video that I showed you before with President Trump and Macron. Now I tried to zoom it, but probably you don't see it because like it's really small. But here you have 24 name entities that the video indexer detected. Part of them are location, and then you have 10 people that it located, and I will skip between them. You will see the timeline here that change, and you will hear the different names as well. So I'm not sure if you see the user that pressing the different, you see this is Bastille, Paris, Canada, and you see that it's changed. Now United States and France. And now let's hear all the places that we hear the word France.
States and France recently took decisive action. In response,
de concert avec nos amis britanniques, les États-Unis et la France,
began 241 years
après les États-Unis et la France, il y a 241 ans ce mois-ci.
Americans fought side by side.
In addition to that, we have names, as I mentioned, and in this video they mentioned George Washington, and I will press his name.
He quickly won the trust of George Washington in the battle, bravely and helped secure and helped
The translate to French.
Il gagna la confiance de George Washington. S'acquitta avec bras.
Okay, and then we will hear President Macron. In addition to the language and name entities, we are doing the speech to text, show the subtitle, and we can also translate into different languages in this tool. Okay, in the same particular video, we also show the sentiment, positive and negative, and the topics, and it's written here, you probably can see, political, France, war, conflict, all types of topics that were discussed in this video. Let us summarize. So we have the video indexer, which developed together, by the way, I didn't mention, with Microsoft Cognitive Services. It actually wrapped up together many ML capabilities. It's built its own algorithmic layer on top of it in order to provide this meaningful insight. We process both video and audio, combine them, and then we have the higher level and the fusion that related also to human language. And as I mentioned at the beginning, if you have some family video that you want to edit, you can try it yourself on www.video.ai, and it's free for trial. Thank you.